we're just going to step away from sort of the nitty gritty of tan theta and sine theta, and we're going to start looking at the graphs, the curves that are generated, that are generated as we increase theta. Okay, so pretty sure you're used to or have seen the sine and cosine curves before, but maybe not the tangent. So what am I talking about here? Okay, so here's a little applet there. If I increase theta, okay, so we always go into the first quadrant first. So we increase, and as we get to pi by 4, you can see that the red line is going up. So as we increase the angle, the red line is getting higher, okay, until it gets to 1, okay, and so pi over 2 radians, our sine function is at 1. It then starts to come back down again as we move into the second quadrant. So as we are heading towards pi radians, we're now back at 0. Okay, so we're moving into the third quadrant now as we move past pi radians. So as we start to approach 3 pi by 2 radians, we've maxed out at -1. And then as we approach 2 pi radians, we're back at 0. Okay, so we can see how within the first quadrant, okay, so when when we're in the first quadrant, we're positive. We're positive in the second quadrant. We then move into a negative value for sine as we move into the third quadrant. It stays negative into the fourth quadrant. Okay, so what I'll do is I'll just reset that. Hopefully I can get it back to 0, close enough. And this time we'll do the cosine curve. So this time, instead of the vertical, we're measuring the blue bit. So we start at 1. We increase it the same way. We're always going into the first quadrant first. Cosine is positive until we hit pi by 2, then it's now negative. So cosine in the second quadrant is negative. As we move to pi radians, we're approaching -1. In the third quadrant, cosine is still negative until we hit 3 pi over 2 radians. And as we move into the fourth quadrant, cosine is positive again. Okay, so we're going to be using some of these ideas. So cosine is positive in the first quadrant, cosine is negative in the second and third quadrants, and then it's positive in the fourth quadrant. Okay, so let's go back to 0 and let's look at what's happening with tangent. Okay, so remember that the tangent is, when we're defining it as sine theta over cos theta, we're actually looking at the gradient of our line. So this green line is going to be our tangent. Okay, so we can see that we've got the green line here. So when we don't have an angle, obviously the gradient is 0. So we'll start to increase theta. Okay, so remember the distance is increasing. Okay, so you can see that the green line is rotating, it's measuring the gradient, and as we approach pi by 2, we're gonna get a parallel line. Okay, so that tangent that was passing through A, we now have a line, 2 parallel lines. They're never going to touch. So that's why we've gone this vertical line. Okay, as we move we're moving into the second quadrant. We've now got this negative gradient, so we're looking for we've got a steep negative gradient, so our purple line should appear somewhere down here. Let's keep, oh, there it is. Okay, so as it's slowing down as we're approaching pi radians, we're getting back to 0. And then into the third quadrant, our gradient is positive again. And it's getting steeper and steeper and steeper and steeper and steeper and steeper until we get to 3 pi over 2 radians. And we have it's parallel to our tangent again. And then we're back to the negatives until we get back to pi by 2. So we have this repeating function which has obviously asymptotes at pi by 2, 3 pi by 2. The next one will probably be